Hi there, you're watching this video because you have questions about number 1 on your factoring binomials mixed review homework. So if I look at number 1, I need to look for that GCF first. So I've got a 4 and a 100. Of course, I'll look at my smaller coefficient, and I know that 4 has factors of 1, 4, and 2. Well, 4, being the largest number there, also goes into 100. So my greatest common factor is 4. I know it's not a variable factor as well because the first term has variables only. So when I remove the 4, 4 divided by 4 is 1, and I'm left with y to the fourth, y squared. And negative 100 divided by 4 is minus 25. Now, if I'm factoring a binomial, I need to look for the difference of squares. Difference of squares has 3 requirements. 3, always 3, and they must all be met. First requirement, do I have perfect square coefficients? This is a 1. Well, 1 is a perfect square of 1 times 1. This is a 25. 25 is a perfect square of 5 times 5. So that requirement has been met. My second requirement is subtraction. And yep, I've got subtraction. So 2 out of 3. Am I going to get that third? Well, the third requirement is even exponents. And I've got a 4 and a 2. Voila, I have met my requirements. So when I'm thinking about the difference of squares, I'm going to just write this down here. I'll be creating 2 binomials. And my first term is going to be comprised of this. And I'm going to take x to the fourth. I'm going to divide 4 by 2, and I'll get x squared and x squared. So x squared is the first element of my first term. I also have to address y squared. 2 divided by 2 is 1, so I have a y and a y. Now let's look at the 25. That'll be my second term. 25 is 5 times 5. So when I think about difference of squares, I will have a plus the second term and a minus the second term. And there is my final answer. I do want to make a quick note that sometimes we miss that greatest common factor, and it's not necessarily over all the time. In this particular example, it would not be over. And here's why. Let's say I take a look at this binomial and I recognize the 4 and 100 are perfect squares right off the bat. 2 times 2 is 4, 10 times 10 is 100. I see the subtraction, I see the even exponents. I'm super excited to just get going right into that difference of squares. So I take my 4 and I say, oh, that's 2 times 2. And I take the x to the fourth, and that's x squared times x squared. And I take the y squared, and that's y times y. So I have my first term with a 2x squared y and a 2x squared y. And then 100, I know, is 10 times 10. So I have a plus 10 minus 10. And it looks good, except that I know my final answer has a 4 factored out. And if you look at these 2 binomials, you can see where that will come from. You need to factor out everything. And 2 and 10 are even numbers. They have a greatest common factor of 2. So I do need to factor out this 2. And I need to factor out the 2 from here as well. Starting to look a lot more like that. Well, remember, multiplication is commutative, so I could have the 2 times 2 together. There's 4, and now I have the x squared y plus 5, x squared y minus 5. So again, I end up in the same place. I've just taken out my coefficient, greatest common factor, at the end. It's usually going to be more effective and efficient to take it out in the beginning. So that's why we say to always check for that GCF first. That's all for this video. Thanks so much for watching, and I hope you understand this problem better.